Our textbook coverage in week 2 is sections 2.1 and 2.2 and all of chapter 3. We're starting to get into some pretty meaty topics here. I wouldn't describe this week's material as very difficult, but it is very important. Early in this course, you'll often hear me say that we're covering material that's not foundational, and we're really only going to see it once, and then probably not again until the final. But for this week, this material is all very much foundational. We're almost literally laying the foundation for the class this week, and everything else will be built on it. So it's really, really vital that we have a good solid grasp of chapters 2 and 3. So let's dive in with section 2.1, which is called frequency distributions. The four main topics here are that we will convert raw data into a frequency distribution and vice versa. And then we'll talk about three particular kinds of frequency distribution called relative, cumulative, and grouped. So let's start with the basics, converting raw data into a frequency distribution, and so we can define this key term today. So I'm going to be referring to some examples that I wrote over here on this sheet. Data is born as a list of numbers. So let's talk about lists for a minute before we convert them into a frequency distribution. So as an example, 25 families were surveyed and asked, how many children do you have? The results that we get from this survey would be called raw data in order of response below. Remember that every number can be described with a sentence. This is very important. In this class, in any math class, we always want to make the connection between numbers, formulas, and meaning. And really understanding things in English is the necessary first step. So for example, let's look at this list of numbers and pick the first number in the list. It's a 3. How could we describe the meaning of that 3 with a sentence? It means that the first family we asked said that they have 3 children. So the next item in the list means the second family we asked said they have 1 child. ... The last family that we surveyed, the 25th family, said that they have 0 children. So every one of these numbers refers, basically corresponds to a family, but more specifically, it counts the number of children in that family. So we really have two important variables going on here: families and children. And I'm emphasizing that now because eventually we're going to be turning this into a two-dimensional graph, which has families in one direction and children in the other direction. And I'm going to be referring a lot to the nature of one-dimensional and two-dimensional representations of data in this course. So I'm just sort of bringing these issues to your attention really early. But for now, let's just talk about how we can turn this list of numbers into a frequency distribution. The first thing really is to just put it in order. So even though we're going to scramble these numbers, we're going to scramble them in a meaningful, important way. And we won't really lose very much information by doing that. When we put these numbers in order, we get 0, 0, 0, 1, 1, 1. We get several numbers that range from 0 to 5 with a lot of repetitions. And what we've lost here is we don't know which family came first in the survey anymore, but frankly, that's not very important. It's really more helpful for us to have these numbers in order from smallest to largest. So the ordered list is really the conceptual basis for all other representations of data, which are going to take the form of frequency distributions today, and then histograms or other kinds of graphs very shortly. There are 25 families in this survey. N is the letter that we usually use to represent the number of numbers. So I sometimes call it the count. So there are 25, what would you say, 25 families or 25 children? 25 families in this survey. And the number of children that each family has ranges from 0 to 5. There are some repetitions, meaning that there are several families that each have 2 children. So now we're getting at some of the basic issues that are involved in a frequency distribution, because these repetitions are also called frequencies. So the frequency distribution would take this ordered list, and it would summarize all the different values in that list, which we're going to call it x. And we do that in the left-hand column. So the different values of x range from 0 to 5, 0, 1, 2, 3, 4, 5. And again, we always remember what these represent. X in this case represents number of children. Okay, and then the frequency distribution will also count these repetitions. So it shows what we call the frequency, which is the number of times that each number is repeated. And we usually call this f of x. F stands for frequency, and it also reminds us of an algebraic function, which is usually on the vertical axis on a graph. So all that is going to be mirrored in this case. So let's take a look at this 3 here. Where did this come from? It actually is not one of these 3's in the list. As a matter of fact, you can see that we have some 7's and 6's over here, and they don't correspond to any numbers in the list. So what they're doing instead is they're counting repetitions. The number 0 occurs with a frequency of 3 times. See? 0, 0, 0. There are 3 zeros in the list. There are 3 zeros. The number 0 occurs 3 times. So that's what this table means. So we need to be able to remember what the left column means and what the right column means, both mathematically and in English, right? The number 1 occurs 5 times, or in other words, there are 5 families that each have 1 child. So that likewise, there are 7 2's, there are 6 3's, there are 3 4's, and there is 1 family with 5 children. So we usually order this list by x, the random variable of interest from small to large, and then of course f is just determined by counting these repetitions in here. By the way, if we add together all the frequencies in this list, we would get 25. And that makes sense because there are 3 of these families, 5 of those families, ... If you add them all together, well, you're really just reassembling the whole list that we started with. So that's an important trick or shortcut to remember. Adding up all the frequencies will tell you the size of the data set. Okay, so that's basically key concept number 1. We need to be able to turn a list of numbers into a frequency distribution. Now, the opposite process is also going to be really important. So to answer questions about a frequency distribution or a graph, it often helps to conceive of its nature as an ordered list. In other words, when you look at a table like this, again, it really comes down to making sure that you understand what it means. Because for the students who don't quite have a handle on that, they just basically see this as a double column of numbers, and they're not really sure what each column represents, and then they get very confused about the questions, let alone the answers. So let me illustrate what I mean here with a new frequency distribution over here. I need to start over with a new problem because it would be too easy to turn this one back into a list. Consider the data represented by the following frequency distribution. If we wrote it out as an ordered list, and then I'll ask you some questions about it. So this is a frequency distribution that has an x column and an f of x column. In the x column, we see 3, 8, 9, 12, 15. And in the f of x column, we see 4, 10, 20, 10, 6. And what I'm asking you to do to get a handle on these questions is, would you be able to take this table and basically rewrite it as an ordered list of numbers if you needed to? I know it's probably too long to actually do that by hand, but I need you to kind of be able to conceive of the concept as if you are doing that, because you're going to have to in order to answer these next few questions. All right, 1 second here. Okay, I just needed to keep my eye on the time because these videos are maxed out at 15 minutes, and I think we're going to take longer than that with this one. Okay, so question number one, if we wrote this frequency distribution as an ordered list of numbers, what would the largest number be? What do you think it would be? Many people would say 20. Do you agree? Is 20 the largest number in this list? Or have you caught on to that? No, 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 no. It's not 20 because 20 is not even a number in the list. 20 is just telling us how many nines there are. So, you have to be able to look at these things and understand what they mean and not just see numbers. So, out of all the numbers that actually are in the list, 3, 8, 9, 12, and 15, the largest one is actually 15. So the correct answer here is not 20, it's 15. Question number 2, what would the most common number be in this set of data? Most common. Some people would say 10 because they see the number 10 written here twice. Is that true? No. There are 20 nines, and that is the most common number in the list because all these other numbers are repeated less than 20 times. Okay? So the answer here is 9, not 10, or maybe some students would even say 20. 9 is a number in the list that's repeated lots, 20 times. That's more than any other number is repeated. It's the most frequent or most common number. Okay, question number 3. What would be the 5th number in this list? What do you think? Some people would say, well, let's see, 3, 4, 8, 10, 9, or maybe they'd scramble these numbers in order and get 3, 4, 6, 8, 9, or maybe they'd say 3, 8, 9, 12, 15. Those are all wrong answers. What would the 5th number in this list be? Well, let's think about writing an ordered list of numbers with repetition. If we took this table and started writing it as a list of numbers, what would it start with? It would start with a 3, and then what would be the next number in the list? Well, it would be another 3 because 3 is repeated 4 times. So there would be 4 3s, and then there would be a whole bunch of 8s, right? Okay, so let me ask you again, what's the 5th number in the list? Aha, here's the first number in the list, the second, the third, the fourth. The 5th number in the list is an 8. So it's not 15, which would probably be the most common wrong answer here. And finally, how many numbers would be in this list altogether? Well, do you remember what we said about counting the frequencies? If there are 4 of these and 10 of those and ... and 6 of those, altogether they would add up to 50. So, and remember what letter we call that? We usually call that lowercase n equals 50, although my autocorrect wants to make it capital. Fine. Okay, so I'm sure that some of you got all those answers right. I celebrate for you. I'm also sure that many of you missed some of these questions, so that's why we're here. I want to make sure that you're really clear on these concepts. So review if you need to, but I hope you're really solid with that by now. Okay, this is going to be a good point to break and start a new video because next we needed to talk about different kinds of frequency distributions.